Hello everyone, my name is Sahar Samir and I am currently pursuing a mechatronics engineering degree in Asia Pacific University. I would like to start by thanking you all for allowing me to present. Today, we will discuss a topic which will hopefully prevent harm occurring to many people. This topic is about developing a wireless landmine detecting robot with image transmission system. Let's start by stating the problem which led to developing the project. It is a known fact that landmines are explosives which are buried underground. This occurs when conflict and wars takes place in a country. Since these landmines are buried underground, it is difficult for military men to find these landmines. Hence, a lot of land surrounding the minefield are wasted since civilians are afraid to approach the land. Most importantly, having these minefields are considered a huge threat to the public and civilians where if these landmines are triggered, it can lead to major injuries and sometimes death. According to the Monitor, around 8,605 people were victims due to landmine explosions. I can personally relate to this problem as my home country, Yemen, have suffered from war for almost 5 years. A lot of people have been injured and some also face death due to this issue. Sustainability can be defined as fulfilling the needs of the present without compromising the future. It has three main pillars which are social, environment, and economic. This project is socially sustainable as it prevents threat on the lives of soldiers, bomb squads, as well as the civilians. Moreover, the robot can be easily controlled using the developed Android application. In terms of environmental aspects, human energy will be reserved for different tasks. Minefields are usually large and a lot of effort is needed to detect the landmine. By using this robot, human energy can be saved. Furthermore, to save energy, the robot was specifically designed to consume less power. At last, the developed robot is considered economically sustainable as it has higher performance, higher efficiency, and lower cost. By using the developed system, the process of landmine detection would be easier than the traditional way. Moreover, properties and land would be revived as well as the relief operations. The risk on civilians and soldiers would also be reduced. Most importantly, a life can be saved and a major injury can be prevented. Moving to the marketing strategy, this robot was designed to be cost-effective and a low-maintenance solution for landmine detection issues. Comparing to saving hundreds of people from death and injuries, the robot's cost is considered to be low. The developed robot also has a faster rate of performance comparing to human deminers, as more space would be covered in less time. Furthermore, by using the robot, a safe environment can be provided for the operators and soldiers as they can control the robot from a far distance. There are a lot of systems that can detect landmines using different techniques. However, most of these projects stop at only detecting the landmine and informing the authorities where human deminers still need to go to the minefield and risk their life. By using this project, human deminers can stay in a safe distance as a robotic arm is designed on top of the robot to remove the landmine. The landmine can then be safely returned to the operators for defusing the landmine. Moreover, the placement of the landmine detector is placed to ensure that the landmine does not explode. The landmine detector was placed in front of the robot so that the detector detects the landmine before the robot covers the specific area.
This video shows the demonstration of the metal detecting robot. The first video shows the various movements of the robot. The robot can move in 4 different directions, which are forwards, backwards, right, and left. The second video shows the metal detector which was designed for the robot. As a metal is brought near the metal detector, an LED will be turned on indicating a metal has been detected. It can also detect small and large objects. The maximum distance of detection is 7.3 centimeters. The small box is made of aluminum foil and acts as a landmine. In this video, the robotic arm would be used to pick up the object once it's detected. The robot can tilt to the right or the left using the GUI. Then, the robotic arm can be used to pick up the object. The robotic arm has 6 degrees of freedom, which are the waist, shoulder, elbow, wrist roll, wrist pitch, and the gripper. The robot's movement can be controlled using the developed GUI. The GUI would also stream a live feed video from the robot. If the metal is detected or an object is avoided, it will also be shown in the GUI. The robot can be controlled from anywhere as there is an access of internet since the communication used is IoT. This brings me to the end of my presentation. To summarize my points, conflicts and war took place in nearly all the civilizations. Many countries have suffered from landmines being buried in their lands, which lead to major injuries and numerous loss of lives, which remains a heavy burden on the country. This issue can be solved by developing a metal detecting robot which can detect the landmine and move it from harm's way, as well as having the ability to inform the authorities. Previous researchers suggested that after the detection, the human deminer is to be sent to defuse the bomb. However, this still possesses a threat to the human deminer. Therefore, a robotic arm is to be designed which can be used to remove the dirt from the landmine and move the landmine away. I would like to thank you once again for your time and attention.